In this video, we're going to continue talking about functions, focusing on two things, the domain and the difference quotient. So, as I said in the last video, when you are trying to find the domain of a function, in general it could be a very difficult problem, but there are going to be certain specific rules that we're going to learn that are based on certain algebra steps that are in your function, and if we use them, it can make the problem a lot more manageable. I will warn you though, is if you are given a function that does not include these things, then these shortcuts won't work and you have to try something completely different. So the first rule that we're going to talk about is that when your function involves a fraction, like this, and you try to think about, okay, what could go wrong here? The main thing that could go wrong is that you might have a 0 on the denominator, and if you try to divide by 0, you're not going to be able to get an answer. So with that said, we just need to make sure that if you have a fraction, that you don't ever divide by 0. So how are we going to do that? We're going to take whatever the denominator is, and by the way, we don't care what's happening on top of the fraction because that's never going to be a problem. All we care about is the bottom. You're going to set it equal to 0 here. We can then factor. You're going to get two values for x here, -2 and +2. But then something very, very important here is that these are the x values that do not work. That if you try to plug them in, it's not going to give you the answer. Whereas the domain is all the things that do work. So let me give you kind of another example that's outside of just math here. Let's suppose I asked you to go out to the parking lot and I wanted you to find me a car that is not red. Find me any car you want that is not red. And you go out to the parking lot and you look around, you're like, okay, here we go. And you point out 5 red cars to me. Okay, you did the exact opposite of what I asked you to do. I asked you to find me a car that is not red, and you found me every car that was red. That's basically right here. If I were to circle my answer right now, x is 2 and -2, that would be the absolute complete opposite of what we want, because these are the numbers that do not work, and domain are the numbers that do work. So then what you have to do is you have to say, okay, these ones don't work. That means the ones that I want are everything else. So my domain would be everything except for -2 and +2. So just make sure that if you have a fraction you're finding domain, you need to make sure that it's everything other than the numbers you found when you solve the equation. Okay, the next thing that you might come across in your formula for a function is a square root. And if we try to think about what can go wrong with a square root, well, the main thing that can go wrong is that you might be trying to take the square root of a negative number. Now, there are times in math where we are going to take the square root of a negative number, and we're going to get imaginary numbers. But for right now, we're going to not want to do that. We're going to try to say that it's not allowed to do. So you want to make sure that whatever thing is inside your square root, that thing has to be greater than or equal to 0. And then we can go ahead and say add 2x here, divide by 7. And this tells us that we need all the numbers that are less than or equal to 7/2, and that will go ahead and give us values of x that do in fact work. So my domain, if I were to put in interval notation, would be all the numbers up to and including 7/2. Okay, so there's our domain for this function. Next up, in part C here, I gave you a cube root, and in fact cube root is 7 minus 2x. It looks like the same thing we just did. However, it turns out that cube roots are okay with negative numbers. There's not a problem with that. So with that said, then there's in fact no problem with cube roots. And in fact, if you have cube roots, it's going to be just all possible numbers are allowed. So my domain is -infinity to +infinity. This will be true for anything that just has a cube root in it. Now the last one, part D here, that's x squared minus 4. That's just what's called a polynomial. There's no fractions, there's no square roots. And it turns out that if it's just a polynomial, it's also true that every number possible works. The domain is negative infinity, positive infinity. So basically at this point in time, you need to know what to do if you have a fraction. You need to know what to do if you have a square root. And then anything else up to now will just have a domain of all real numbers for a formula like this. Now, of course, if they give you a picture, there's a different type of issue. But regardless, this is how we're doing domains right now. I will say in the future, if I give you other formulas, things like logarithms and other functions that we're going to see, there will be different rules for the domain. But that's just not what we're at in this video. The second thing in this video, and this is probably one of the most challenging topics in this course, is the idea of a difference quotient. Now, usually you're given this formula, f of x plus h minus f of x over h, and they ask you to work it out. They don't usually explain much about where it came from. I will give a quick explanation right now, but it's not going to be a perfect picture here. It's mainly, this is something that you're going to use when you get into calculus class. This is a pretty big thing early on there. But the idea is you're going to have some sort of function here. And if you have an x value x, then that y value is going to be f of x. And then if you move a little bit to the right over here to a new place, x plus h, so that means you moved right h units, then your new y value is going to be f parentheses x plus h. Because remember what this f parentheses means. It means what is the output when you have that input there. So f parentheses x plus h is what is the output when your input is x plus h. And if you do that, if you just find your slope formula here, your slope formula is going to be exactly this thing. So the idea is slope at this point in time can only be used to find the slope of a line. It can't be used to find, say, a slope of a parabola or something. But in calculus, we're going to learn a way to extend the idea of slope to other graphs. And the key idea to get there is this difference quotient. So when you take it in your pre-calculus class or your college algebra or whatever you're first learning difference quotient in, it seems kind of oddball. We do it in one section, then we don't really ever deal with it again, and it seems like it has no purpose. But once you get into calculus, you finally see what you need this for is to try to generalize the idea of a slope when you get into other functions. Regardless though, let's do a couple examples here. So for these, they give you a formula, and then what you're supposed to do is you're supposed to work out what is f of x plus h minus f of x over h. So you start by taking your formula, and everywhere you see x, you go ahead and replace it with x plus h. Now I did that here, and then I distributed the 2 in so that it looks a little bit nicer. Then I need to simplify this mess, and I will go ahead and multiply top and bottom by the LCD here. That will allow me to clear the fractions on the top. So once I distribute that in, I can cancel something out there. I would get 2x minus 1 minus 2x plus 2h minus 1 over h times 2x minus 1 times 2x plus 2h minus 1. I would absolutely recommend you do not multiply out that mess on the bottom there. It will take you a lot of effort, and you really aren't going to be gaining much from doing so. So just leave it in its factored form. However, we will go ahead and distribute the negative sign in. And if you do that, you're going to have 2x minus 2x is going to cancel. Minus 1 plus 1 is going to cancel. And you're going to be left with just a minus 2h on top over h times 2x minus 1 times 2x plus 2h minus 1. And finally, your h's will cancel, And the answer we want here is negative 2 over these two things in the bottom here. And I will give you a little tip here. For every one of these problems, your h should be canceling out at some point in time near the end. If your h does not cancel out, then you went wrong somewhere. As you can see, these problems are a lot of really messy algebra. That's what we're going to be dealing with here. Now for the second one, I gave you a square root, which is the hardest version of these that we're going to see. So let's go ahead into the difference quotient. Replace our x plus h here, 5x plus 5h plus 3, minus the original thing, 5x plus 3 over h. The problem is this time there's no common denominator for me to multiply by. In fact, at first there is no nice thing to do. But it turns out that when you have square roots like this, that the trick is you are going to multiply top and bottom by the conjugate, because that is the way that you are going to rationalize the numerator. I know that in your previous algebra classes you probably only rationalized the denominator. That was something you had to do quite often. But it turns out that right now we don't need to rationalize the denominator, we need to rationalize the numerator. So I'm going to go ahead and rewrite this here. And then I'm going to multiply top and bottom by this conjugate, which is the first square root plus the second square root over the same thing on the bottom. And then when I'm multiplying the top there, instead of actually writing out all the detail, because it's long and messy here, I want to point out something to you. That when you have a minus b times a plus b, that's the same as a squared minus b squared. Again, this is the reason why we're doing it this way. So if I square the first thing, I'm squaring a square root, I would get 5x plus 5h plus 3. And then I'm subtracting the second thing squared, which is 5x plus 3. You square the square root. The only problem, though, is that, again, I'm subtracting the entire b squared, so I need to put parentheses here, all over h times this square root mess here. Then, once you go ahead and distribute your negative sign in, some things are going to cancel as before. You're going to be left with 5h on top over h times these two square roots. I know it's a mess. It's not very well written. But just kind of copying the same thing down. And of course the last step, as usual, is going to be canceling out that h. And our final answer is 5 over these two square roots added, and this would be your difference quotient. Now I will say that right there is as bad as it gets. You're not going to get anything worse on these difference quotients, but it is going to happen, so you need to be able to deal with this.